send an email this morning to let you know the general plan for the remaining of the semester. Do we have any question about the upcoming assignment task? No. Do you regularly check your grades with each assignment, right? Okay. Yeah. So if you have any review these grades, and if you have any question, just let me know. Uh, I try my best to keep updated with the grading, but sometimes you may miss one or two grades, especially those late submissions. And remember, you can improve your grade for the first two projects. Okay. But the deadline is a little bit different from the last project, so I need you all to finish this by December 3rd, so I can have enough time to revisit those projects and grade them. On the 4th, I'll review all those new submissions for project 1 and 2, and then update your grade if I see any new submissions. So for the last project, basically you learn a new algorithm, and then you use this algorithm and the previous algorithm to find the best prediction model, and then deploy it to a REST API with FLASK. So this is the overall architecture, and this is the framework for creating the website. It's really very, very easy. In the last cohort, there were a few students who gave up this last task of creating the API, but it's really very easy. Okay, we'll demonstrate it today. So, wow, what's a REST API? We often say it very often, API, and the full name of this is Application Programming Interface, which is generally a set of rules that define how those applications should communicate with each other. See, behind the application, there are different modules, different languages. For example, usually we use ASP, or we use JavaScript to develop the website, the front end of the website. But behind that, for the backend, you could use Python. For example, we are using the prediction models, and usually those are written in Python. So, and these two applications, they need to communicate to each other. They need to get the this need to get the data to this from here, and send the request to here, and then this need to return the data to here, right? So you need some language, common language to communicate this. That's called the API. So right now, usually you use a JSON, and in the old time, they use XML to communicate. We are familiar with the JSON format of JSON. Yeah, basically it's like a dictionary, pretty thin dictionary. Right? So this REST API means that the design principles of this REST called representational state transfer architecture style. Okay. Generally, it supports high-performing and reliable communication at scale. So with this link, you can learn more about this architecture. This is another example. Why do we need this API? So for example, this is the database, and this is the front end, the website I need to build. And I remember when I first learned programming, was like a website support or administrator. All we do is this is a SQL, right? Database is SQL, and then here you write some ASP, or I think it was an ASP, yeah, ASP, and then you just send the request as a SQL and open the SQL and then insert and do everything directly, interactive directly with the database. And now usually this is a more common structure. You have the API in the middle. This is the backend, maybe SQL, that maybe Python to communicate with the database. And then in the middle, they use the API to interact, like an interface in .NET framework. So you don't directly use the class, use the instance, but instead you use the interface to communicate. Or why do we need this structure? What is the advantage? Intuitively, this should be quicker if you just directly communicate with the database, right? But why do we need to add an API here at the middle point, as the media for these two items, two applications? There are a few reasons. First is security. Now, if you directly get from the database, you have all the script here, and some people can easily hack this and can see the script. And in the last cohort, we had a lesson about web scraping. So if you use the index, like if you open the index and inspect, you will see all the script. What are the names of those variables? Those you call columns from the database. Everything is there very clearly. So add this API, add another security. You don't interact this with this database. And the second one is adaptivity. So here, probably this is a website to a computer. So this get data from the API, and then one day you want to add some other applications like a mobile phone, an interface to mobile phone, or some other things, and these could just get data from the API. These are like data from the database already there. So this is very convenient to get the data just from the API. Okay, so this is adaptivity and modularity. Modularity, which means that you see the languages are often updating. Maybe one day I cancel this Python. I don't want this Python anymore. Or I would change this JavaScript. And then you only need to change this interaction with the database. And then you connect to this API. So it means you only need to change one module instead of changing the whole system. The last one is collaborate. So this is related to security. Now, with the API, it's more secure. You don't directly interact with the database. So a lot of people, you can open this API for other developers to develop whatever things they want, like Twitter and some of those websites, Facebook. I think they all have the API and they are open to public developers. But of course, without this, if you directly have this database, you cannot open it to the public. Right? But with the API, okay, the data is there. These are like existing data, fetch the data to clients. So it can be open to the public for development. So that's the last one. Collaborate. You can invite more people. It's easier to collaborate and more secure. I guess we are all very familiar with these requesting methods here for common APIs. The first one is GET, which means fetch the data. The post in SQL means insert new data. And delete and put means update the old data. Right. Next one I want to mention is the FLASK web framework. So web framework is like a template you can have to easily develop the website. It's like the .NET framework. You can easily just follow those templates and then build the website very quick. And this is not very popular framework, but it's still used by some websites. Yeah. It's not as popular as the .NET framework or Angular. I think .NET is also not that popular actually, but I teach that course. Okay. So next we will demonstrate how to build the prediction model and then save it and then use it put it onto the website. The first thing we need to do is build the prediction model, which we have done many times in the previous lessons. For example, here I build a model, okay? Um, yeah, I just got everything ready here. I imported this data set and then I built a model with decision tree. I minimized the feature selection, feature engineering steps. And here I just build this model called the decision tree, CLF. Okay, it's basically a decision tree model. And we have learned like using build the linear regression model and then use the linear regression to predict the result for the new dots, right? We have done this quite familiar, should be. Um, uh, um, so okay. Just a quick video. Run this again, okay. And after I build a model, I could use this to predict the X test, XY. Oh, no, X test. We'll use it to predict the X test and the, it will tell me the Y, the predicted Y for all these data points. Right? Or I can get a score of the accuracy score. So this accuracy score. So the next thing we'll do is to save this to pickle file. So this is a common file we use to save the model. In some cases, you also see PT. I do probably some of the code. I just save a file with no extension at all. That's also fine. But commonly you okay. So like sometimes I save it as maybe I save it as like the model in some neural network. You save not the model. The model will be the same, the decision tree, but you save those like numbers of we call those numbers a dictionary, state dictionary of the model. But here we saved the entire model. Okay, so what you need to do is just use this package pickle dump and what model you want to dump. This classification model, and where do you want to dump? I want to save this model as this file, and WB means write binary. Okay, so if you execute this line, what you will do, you should expect a new file, model.pickle, right, saved here in the under the same directory. Okay, see, it's here after I save it. So and the next step we could do is just to load the model. Here, this model is saved in cache, so I can just directly use it. And also now it's saved in model.pickle, so I can load this model. I call it decision tree, or I can still call whatever name you want. And after load this model, you just use it as what we did. You can predict, you can get the score. So if I predict the X test, it gives you the result. It gives you the result exact same as this one should be. See, it's exactly the same result as the one we just used. And you can get the score is the same. So this is just one extra step. You save the model and load the model. Very easy, right? Okay. The next thing we want to do is to put the model into the FLASK framework. We did test it. There are only 3. It's not necessary, okay? There are only 3 files needed to be created. The model.pickle, we already did it. It has a model in it. And then the app.py. F.py is the API. It communicates between the Python, the model, and the front end. That's HTML. And this is the front page for client. They input their loan or other loan information. They put their credit history. They put these variable, their gender, dependent, their information there, and then this APPY gets the data from the index and then use this model to predict, to return a result. Okay, that sounds pretty easy, right? Okay, so let's do this step by step. So the first thing we do from easiest, this is actually already done. So there are only two steps. So the index HTML usually have the user inputs and the return the response. So pretty easy. You see HTML and this is a form. It's a form. It has several inputs: loan amount, credit history, total income. And we do this later, okay? Okay. Well, I like to use the Visual Studio Code, or you can use any other apps, but I like to use this one, so I build a. One thing you have to remind it is for the FLASK framework, you put all the HTML page under templates. Okay, put all these under templates. So here I put this HTML under the templates, and I put all these code. Basically, it's just a form with several inputs, and then this is a submit button. Okay. We'll do this later. Later. The next thing we do is to create the we need to move this model.pickle into this framework. So let's find it and move this under here, decision tree. Okay. It's not here. Just to move this to here. Okay. find that. Okay, so we have included here. The next one is the big one for the app, for the app.ui. So you have to import all these packages. We have NumPy often. FLASK, you probably need to install this FLASK. Like it's this one. This is the package. And this is the we call this is called a class, and you create an instance of this class. Right? So let's do this step by step. Okay. This first one is to first one is create an instance of Flask, and then this one let's just create an index page. Pretty easy. So this is the route. This is the root route, which means when you first log into the website, or which page it should direct to. So this is index. If you come to the root directory, it will go to the index function, and it will show render, means show, right? Shows this HTML. Okay, that's all we need, and then we just add the main function and just run it. Okay. Okay. So this should return us. This should return us the index page. Want to debug. We'll go back to see. Okay, didn't have FLASK on this one. Sorry, I installed FLASK, so now it should be installed. Try again. See, it tells us it has the website running on this portal. So let's open, see if it's working. Basically, we just created a route index under the route, right? And under the root folder. The URL, I didn't put that in. I thought I didn't put that in. Okay. Mhm. Okay, see, the first step is done. Oh, it's just an index page, and then it just we used the FLASK framework and build an index page, and it's rendering fast. So the next thing we want to do is to add another page. This page basically communicate from the index and to the pickle model. Right? So there are two things that you need to do, which is here, which is getting the two things that you need to do, which is load the getting the data using the data from the index, and then getting the data from the index, and then give it to the model from the pickle, and then returns the result. So if we look at this code, this prediction, this is a second page prediction, and this goes to, so this second URL, when it enters, it goes to the index in the route, the root of the folder. And then we create a second URL. If it goes to predict, then what it does is to activate this function. This function, it takes the values from the index form, and then give the values to the pickle model, right? Basically, so let's do this one step by step. So this is a new URL we added called predict, and then this function predict. What it does is first is to get the values from the form. So I'll call this maybe like a features or values. Request.form.values. It's actually needed the form name and to give the name to the form. Doesn't need a form name. Right. So this URL predict activates this form. So for this one, it get actually have multiple values, right? Has this how many inputs are here? Has three inputs here. So we need to give it to. We need to get the each of the input. So we need to try. And this create should create a list. And then we give this list to the prediction model. Did we load this prediction model? Here we haven't yet. So we just basically use a pickle.load. Pickle.load to load the prediction model. I'll just copy the code we just used here. .load. Okay. Next one we just actually what should we do? Use this input to use this input, give this input to the prediction model, right? So you guys can help me. You all can help me to write this. Here I return the result. Okay, save the result. I think that's all. The next thing we want to do is to give this result back to the index page. So I'll say here I use a variable to I'll use a variable to show this result. And here we need another line to give us the result to the index page. Again, we use the surrender template, and then it goes to the HTML page, and then it takes it gives us the result to this variable. Okay. So pretty same. Just use another name so can be distinguished. Okay. So this result comes from where? Comes from this one. The
Well, have return twice.
oh, okay. So this result is the one we get from the model. And this result, what is this result? This is the variable we pass to the index HTML. Here we used a variable called predict. So I think that's all. Other things remain the same. So we get this new URL. Then we added the URL here. We added the URL here. So if we then submit, it will activate this new URL. Right, let's see and see what kind of bugs it will give us. Didn't give us any bug, which was good. So the question here is, I have more than 3 variables, right? And then the model takes how many variables the model takes? I think we didn't remove any features, so it takes multiple variables. Variables should match. Add one. Oh, it has more than 3 variables. So either you need to add all these variables to the HTML, or if not, you need to give the default value. You need to, other than these values, you need to add some default values. So the number of feature would match to the number of feature in the pickle model. I would just do this step to add all these features in the index. Okay. Let's see what else we need to add. we have the gender. So one by one. Species. Yeah, so another thing you see is if with some of the variables that could be removed, you should remove them. That's why we simplify this model. You see, if some of these are really not relevant at all, then you could simplify the model, and that will simplify this app, the inputs from the users as well. They are usually impatient to put all these information into your system. So, this will be okay. I'll just quickly copy all these. Amount term. Optic area. I don't understand why I didn't. I should simplify, reduce some feature at the beginning, so the model will be simplified. Yeah, I guess that match the gender, married, dependents, and education, employee, no amount term, credit history, optic area, total income. Total income, that's all. It's good. And because our model uses all integer numbers or at least numerical numbers, so when you import, you should also import all numerical numbers, not not like a male or female. Yeah. Of course, you could do a few steps like here for the index. Here you could add some extra steps to change the value from a male female to integer. Or you could do it here also, but I skipped that step. Okay. What was this? Long amount. 1 layer, 2 long amount. It's a long amount of time. What was this thing? Oh, that's education actually. Should be education. Yeah. Oh, method object is not iterable. So there's something wrong on this line. Correct. So the crystal form dot values look correct, right? I don't think it's necessary to change it to numpy array. The list should work. Let's see if it will build. So let's see what's the problem here. Don't think method object is not iterable. So this is a method object. Doesn't return the values and which means you all see the problem, find out the problem here. this one is not necessary. So let's see here. Request of form dot values. That's the correct. I'll just change this to integer. It's actually even not necessary to change to integer. Just need this is
Didn't know that the DC file has only possible store.
Oh.
Sorry.
Oh, you're fine. You just yeah, debugging. Okay. This work. So okay, I guess that's a problem. So it's an attribute. Should it do the trick? Okay, it did return a result 1. So yeah.
Better enough.
Better enough. Yeah, yeah, you could like refine this page a little bit to like make it a little bit more beautiful, and then add this. This is your or whatever your loan status. And 1 means approved and 0 means not approved. Of course, you can change this variable to I call text. If result is something like if result is 1, or else if result is 0, then prediction result is this result. If result is 1, okay, the value is approved like this. So you can just change this variables easily. I believe you all can. So it's again, this don't give up this step in project 3. It's just include 3 page, actually just 2 page. The index page is just an easy HTML page, and then this app.py as just a few elements, right? A few sections. One is a load the pickle, create an instance here, and then this is the index page directed to the show the HTML, the basic HTML, and this is the second URL called predict. This predict basically again goes to the index page and return this result. Of course, in this function, it did get the values from the form and then use the values to predict a result from this model. So some of this code is actually not necessary. These are not necessary actually. You can even delete this int, some of these also. And you're welcome to change this HTML and to beautify it a little bit, but this is the basic requirement. Just to build the model, build the API, and you should zip this whole file, whole folder, 3 files. Zip this whole folder when you upload. Okay. Right, any question? Oh, okay. Oh, there are 2 last slide. So as you see, sometimes we changed the inputs in the original data set. These are male, females. However, in the model, now most of the models we have learned that they only take numerical values, right? You have to change them all to a numerical or into dummy variable. And if there's any change, data processing steps, you should also do it for the model. For example, here I have a loan amount. That's 5,000 and 6,000. And in my model, if I use the k nearest neighbor, I may have scaled the number. So the number you give to the model, to the prediction model, is 0 to 1. However, the original number you got is 5,000, 6,000. Then what you need to do is to change the 5,000, 6,000 to use a scalar. Use the same scalar to change it to 0 to 1 also. So here's the code here. See, after you do the scalar, fit the scalar and build the scalar, you can also dump the scalar. And you can also dump the scalar and then load the scalar. And the next step is the same. So after you use the scalar, you can load the scalar here, and then some of the features, all these features, if you use k-nearest neighbor, right? And here, after the step, you can use a scalar to fit. You loaded the scalar, and then you can use scalar to fit and transform the features. So that's an extra step if you use the scaling or some other data processing steps. So this is another example. If you have dummy variables, should you do? So for example, here, I import 2, 1, 0. Here. In the decision tree, I didn't use it. But if it's another model like k-nearest neighbor or logistic regression, then you should change this to dummy variables. You have to change this to dummy variables to the model to feed the data to the model. And your input, of course, is still 2, 1, 0. So what you have to do is also to change them into dummy variables. See, this is the code. So you could add some features. So for example, this is a feature 2. Feature 2 is a dummy variable. So if feature 2 equals 2, okay, this actual, you added some actual dummy variables here, and then you give it to 1. It's a little bit complicated. So you need to get this concept that you need to have the same feature, exact same features of what you feed to the model, not the original features you get from the HTML. Okay, there may be some feature changes. Yeah. Alternatively, at the input, you can have those. For example, if this one has a rural, semi-urban, and the input, the HTML, the input in the HTML could also be three inputs individually for these features. That's also fine. So, so this is one thing you have to keep in mind when you use a scalar or any feature transformation before you build the model. Okay. That concludes our lesson. Thank you all so much for your hard work this semester. I really enjoyed the class. And yeah, don't forget to go to the course evaluation and give us some feedback. Okay. Any question about the project or assignments? All good. Yeah, we have no more lesson, but I'll be here to answer any questions. So you will feel free to come here. You're welcome to come here to work on your projects and assignments. Okay. And for the previous project, you got my feedback. You're unsure about any some of the feedback, you can ask me. You're improving. You're improving project 1 and 2 during the break.